Hello, everyone, and welcome to today's event on exploring GPT models, applications in work and higher education. My name is Sofia Hedén, and I am head of talent programs here at AI Sweden. So fun to see that a lot of you have joined us here on site in Gothenburg, and I also know that there are a lot of people who have joined us online. Today's agenda is as shown on the screen: a brief introduction to AI Sweden, an appearance by Microsoft, presentations by all three student teams, a wrap-up talking about next steps and how to get involved. And for those of you who are on site, we will end the event with a poster session where you will have the possibility to closer explore the projects and try out some demos. For those of you who are online and unable to attend the poster session, please feel free to reach out with any questions, comments, or suggestions afterwards. I also need to inform you that in case of emergency, follow the exit signs to the nearest emergency exits as you see to my right and where you entered the room. And there is a heart starter in the reception. AI Sweden, formerly a program within Lindholmen Science Park, is the National Center for Applied AI in Sweden, and we are represented regionally at many places around the country. We are neutral, nonprofit, and broadly funded by the Swedish government via Vinnova and by our around 110 partners from the private and public sector and the academia. Our mission is to accelerate the use of AI for the benefit of our society, our competitiveness, and for everyone living in Sweden. And we do this by facilitating collaboration in different ways, for example, by setting up talent programs like this together with our partners. And we have done this in different shapes and forms since 2021. I believe that the word accelerating is crucial to emphasize here when we're talking about the GPT Summer Internship Program, which is today's focus. Earlier this year, we saw that GPT was already used widely around the world, and we realized that we have to accelerate the use of generative AI also here in Sweden. So how do we do this? We talked to several partners who expressed interest in projects around generative AI, and we then needed people working on it. We know from experience that talents in our talent programs can develop organization capabilities and capacities. So in May, we set up a recruiting process where students applied as teams consisting of competencies within machine learning, data science, and software development. We set the bar really high and recruited the 3 teams that we have with us today, and you will soon learn more about their success. We believe that there are 3 elements that are very important in creating value. Of course, there are others as well, but today I want to talk about boldness, speed, and collaboration. We set up this program together with some very bold organizations: Zenseact, Västra Götalandsregionen, and Chalmers, in collaboration with Professor Dan Frey at Mechanical Engineering at MIT. These are partners from 3 different sectors: corporate, public, and academia, which creates a good and interesting mix. We also, as I mentioned, recruited the students, and we selected them not on the basis of their existing expertise around generative AI, but rather their boldness to accept this challenge. Neither students nor partners had done this before, which speaks of great boldness. Moving at a fast speed was crucial to set up this program and started at the beginning of the summer. And all the participating partners stepped up, making this a fast process. And Microsoft also expedited the process by offering infrastructure. They will soon talk about how they did that and how they have worked with the program. And lastly, collaboration, which is often mentioned as the key in any project or in anything really, and so also here. We have all been working together on the setup, the projects, the infrastructure, and problems that arose. Things that had been very difficult for any of us to do alone. So the talent program, the partners, and the students illustrate what can be done when collaborating. I really think that the presentations you will hear in a short while from Jesper, Claes, Viktor, Oskar, Henrik, Felix, Johan, and David will display that AI Sweden's talent programs are a great platform for boosting any organization's capabilities and capacities. But before we let the students on stage to present themselves and their projects, I would like to welcome Caroline from Microsoft, who will share a few words about how they have accelerated the program.
Thank you. Let's see. Thanks. Good morning. Did everyone get some coffee? Sounds really, really good. I think we're up for some interesting presentations here moving forward. My name is Caroline Attelius. I oversee manufacturing and automotive within Microsoft Sweden. I have online also Gialle Elehu, who's a colleague of mine who oversees the technical transformation programs in Sweden. I think both of us have been working for the past 10 years or so with AI-related technologies. So this is by no means new to us. The thing that is really interesting these days, however, is the medial exposure that AI has gotten recently, meaning we're finally catching up society-wise with all the great benefits that we can get out of this. So I was actually part of a couple of projects 6-7 years ago when we were exploring cognitive services, for example, for detecting emotions while people were driving their cars. We were looking into how to make sure that the right Uber driver were actually attached to the right vehicles with face recognition. We've been doing text-to-speech pieces, and we've been doing data mining for looking into how to drive better service protocols and hand that over to R&D. So loads of interesting things happening over time. We're now in a new era, right? Everyone has heard about generative AI. Puts new capabilities to both companies and individuals in terms of how we measure and do our everyday life exercises, but also how we explore this in our professional lives. And this time around, we got a rapid question coming through saying, can Microsoft support a bit infrastructure-wise? You have data centers globally, you have the services we need to explore. And I think it's a super good match also from the perspective that this is exactly how we go about it ourselves, that we do it in innovative and really small sprints, and we continue to evaluate and drive this in any meaningful way. And for that, we need great people with a lot of curiosity, like the students we will see here today. We also need the academia and companies to step up and come with their potential challenges and opportunities ahead, and then we can start exploring. So I think there is one slide just also summing up that from our end, we see that AI will actually reinvent every industry. I mean, this is only the beginning of exploring what this type of technology can do to whether it's healthcare, whether it's our industry landscape with production facilities and supply chain, whether this is the retail experience and so on. So I see this as an opening. I see this as continuous work, and I'll also invite all of the people listening in here today to come up with ideas and challenge, and we can also be a good counterpart in exploring things jointly. So with that, I will hand it over to the first group that is represented by the Zenseact team.
Yes, thank you. Hello, everyone. During the summer, we've been working with AI Sweden and Zenseact to explore how generative AI can help increase productivity. And before we present what we've been working on, I would like to introduce the team quickly. All three of us presenting here today are on our 5th year in complex adaptive systems at Chalmers, but we also have 2 more team members from Zenseact. And now first, our project supervisor, Yudi, will present some background to the project.
Okay, so my name is Yudi Chen. I'm the product owner in Zenseact. I'm also the product manager of Sensect. So I will give a background introduction about Sensei so that we are on the same page. So Sensei, in brief, it's a generative AI assistant on Zensect's own data. Why do we want it? Let's start from 2 actual pain points in Zenseact. So first one, knowledge boom. In a tech-heavy company like Zenseact, our knowledge and information keep booming over time. So they can come from anywhere, like new technology, new requirements, new tools, and all that. And so for Zenseact people, it's our everyday life. We have to face with this massive knowledge and information every day. So how do we find the relevant content today? So the current practices are reading documents, searching in Confluence, or asking around in help Slack channels. However, take the Confluence page search, for example, we find that people rarely get what they want right after the search. More frequently, they have to mine the relevant information from thousands of search results themselves. And this is and people suffer those pains every day, like information overload, content switch, irrelevant information, time consuming, and high labor costs. So fortunately, we have the last results help Slack channels. We have nice and supportive colleagues there to help. This approach looks nice. However, it passes on the issues to somewhere else, thus caused the second pain point. So as of today, there are 254 help Slack channels in Zenseact, and they are administered by various group of people. So now let's imagine if you were a new worker in Zenseact, how overwhelmed you would be by these 254 Slack channels. How long it would take you to figure out the right places to ask the right questions. And if you were an administrator of such channels, how frequently you would be frustrated by the questions which are asked again, and again. So the overall experience is so painful, we don't want it. Then what do we want? So we want every worker in Zenseact, regardless of newbies or experienced ones, they are able to get the relevant knowledge and information. And we want the help Slack channels administrators be relieved, and so that they can go for more creative works. But how can we quickly collect and find the relevant content from this vast knowledge base? And how can we present such content to people in a neat and cost-efficient way? So this sprint, when ChatGPT hit the public, I was thinking, can AI help here? If the answer is yes, will our data be safe? And I'm so happy that this summer, those young talents came to help and provide the answers with Sensei. So now the stage is yours.
Thank you. To answer Sensei's problem, we came up with Sensei, a generative AI chatbot. When a user asks Sensei a question, it will attempt to fetch the most relevant sources from the company's internal documentation, and using that information, generate a suitable response complete with sources for the user. Sensei is currently using Slack as its front end, and it's powered by OpenAI's language model, GPT 3.5. So we prepared a quick demo to show what Sensei is capable of. First, this video, we can see I'm asking Sensei where I can print my documents at Zenseact. It answers with the location, but also how to use the printer system and show sources. I'm using Windows, I'm asking for more detailed instructions for Windows. And it'll give me a list of instructions. So we can break down the features one by one. First, as I just showed you, you can chat with Sensei. just by tagging in a Slack channel or sending a DM. And it'll provide an answer that's backed up by the most relevant sources for that question. You can just chat with it in a follow-up question by just tagging it in the same thread. You can also give it feedback by just reacting with a thumbs up or a thumbs down on the message, which will actually help improve Sensei over time, as the feedback is stored and used to filter sources in the future. If you want to see more sources than just the one shown first, you can react with the eyes emoji and you'll see all the sources available for Sensei at the moment. You can also give some more in-depth feedback. So if you react with the speech bubble, you can write your own feedback, whatever you want. You can also tag Sensei in an existing thread. So for example, me and a colleague is discussing something and we can't reach a conclusion. You can just tag Sensei and have Sensei read the entire thread and come up with an answer. You can also ask Sensei to summarize a long thread that you don't want to read yourself. And finally, you can upload your own files and Sensei can read and analyze and provide feedback on those files. So for example, if you upload your own KPI statistics or have it summarize meeting minutes, or you can have it help you with code. That was about it for the features. Now, Victor will talk a little bit about how it all works.
Yes. So to retrieve the relevant sources for Sensei from the large amount of information, we need to be able to compare the relevancy between the sources. And this is where embeddings come in. Embeddings are a vector representation of the text that captures the semantics. It's like a quick summary for the AI. And then to be able to store and search through these large vectors, we need a vector storage. And for this, we chose ChromaDB. It is an open source database system that is created for just this purpose. Then, when we need to identify the sources or what sources are semantically close to the question, we can just calculate cosine similarity and then retrieve the top 5 sources, for example. And here we've created a color coder overview of our product. It is in the pre-processing step, which is colored yellow. A developer needs to provide Sensei with data and documentation. This involves downloading the sources that Sensei should have available as text files. These sources are then embedded into a list of vectors that our AI can understand. And then they're stored in the Chroma database locally on our computer or a server. Then when Sensei is active, which is colored green, Sensei receives a question from a front-end user interface, which in our case is the Slack bot. It searches through the sources to find the most relevant sources for that question. A prompt is then passed through ChatGPT, and then the answer is formatted and sent back to the user. And after working with OpenAI during the summer, we learned a lot and summarized some simple guidelines. A main question that came up a lot was what data Zenseact felt secure sending to assure OpenAI. But our conclusion was that many companies, including Zenseact, are already very dependent on Microsoft and all their services, and we already trust them with their data. And this tool should, of course, be no difference. And Microsoft also states that no data is ever saved after it's been processed. Since we're using Slack as a source, which are normal chat messages, we spent some time cleaning them from personal information like phone numbers and names. And lastly, the main limitations we found working with the current GPT and embeddings is that it's very sensitive to how you phrase the question. The same question can return different sources and different answers depending on how you phrase it. And there's also a limit to how large each source can be because of the embeddings. So we have had to split up large sources into smaller chunks to capture the semantics better.
Yes, thank you. And regarding the future of the project, it would be very interesting to explore some other models. One potential upgrade in the near future could be using GPT-4 instead from OpenAI. This should help improve the quality of the responses and would hopefully in the future allow for images to be processed. Another possibility is using a local model instead, such as the newly released Llama 2 from Meta. The performance of that seems to be roughly on the same level as the 3.5 model we're using right now. And doing all the computation locally would have the benefit that no sensitive data ever has to leave the company. The downside, however, is that it requires a lot of computation to be run. And going forward, our project will be handed over to another team at Zenseact that will continue to maintain and further develop Sensei. Yes, so thank you all for listening to our presentation. And if you're interested in learning more about our work, you can come join us at the poster session afterwards. Thank you.
So thank you for this, Team Zenseact. And while we get our mics working, I would quickly just introduce the next project here, which is the team VGR. And we have been exploring use cases of GPT models in healthcare. And this was made in collaboration with VGR and also Sahlgrenska University Hospital. We intend with this presentation to go through what we have done, how we did it, but also what could be learned from it and what the future holds. So let's start right away. First, we quickly introduce the group. My name is Oskar. I'm a 5th year engineering mathematics student here at Chalmers. Or not here, but at Chalmers. And then we also have Felix, who is a computer science student. He will begin his 5th year this fall. And finally, Henrik, who is a software engineering student here at Chalmers as well.
All right. Thank you for that, Oskar. So at the start of the project, we were given 4 use cases of LLMs in healthcare. So the first one was a patient assistant, which could access the personal documents of a patient and help with tasks like summarizing and fetching information. And the second use case was a doctor's assistant, which worked in the same way as the patient's assistant, but it accesses several patients' documents. And the third use case was an intranet assistant, which gives quick and easy access to the intranet, like contact information of like the hospital and so on. And the fourth use case was an internet assistant, which is designed to use selected sources to produce high quality answers. And in the end, we created a single web interface with 2 kinds of users: a doctor, which can access the doctor, the intranet, and the internet assistant, and a patient, which can access the patient, a patient, and an internet assistant. And yeah, we will see a demo of this in a minute. So some background. Today, there are several models that can be considered when building such an application. So first, there's GPT-4 by OpenAI, which is the successor to GPT-3, the model behind ChatGPT. And it's about 1,000 times bigger compared to the next biggest model. And this is the top performing general LLM right now. But the problem is that it can only be accessed via an API. So sensitive data would leave the hospital. An alternative is Llama 2 by Meta. It is significantly smaller, but you can run it locally, but it requires some expensive hardware to do so. But we see it as a good contender for this kind of application. And finally, we would like to mention Palm 2 by Google. And even though it's even smaller and has limited access right now, it holds the state of the art in medicine question and answering after fine-tuning on a clinical dataset or a number of clinical datasets. And it shows that even if the model is very small, it can still perform well at certain tasks after fine-tuning. Thank you.
So now it's time for us to show the application. And we will first start by showing it from the patient's perspective, where you can log in with a patient ID and a password. And this is the main interface, chat interface. You can ask a question, for example, could you please summarize my latest visit at the hospital? And it will give us summarization and also how it got the information. And in this case, it was from the medical records of the patient. And here we also display that you cannot, as a patient, ask for another patient's medical files or records, since this is very important in a medical setting and should not be allowed. Finally, here we also showcase that we can switch to the internet assistant and then ask for a more general medical question, where we want to perhaps find the differences between 2 different diseases. And in this case, it then uses the source 1177 to find information about these diseases. And after things for a while, it then generates an answer any second. Yeah, and as you can see, it gives an answer and also the sources if you want to read further. So yeah, we can move on. And right now we show you the same application, but from the doctor's perspective, where you log in with your username and password. And it is very similar. You can still ask a question, for example, to summarize your patient. But you can also ask more, for example, how does the treatment plan look? How does it have anything scheduled, etc., etc. But it has one extra feature here, and it is the intranet assistant, which handles more administrative questions like where does people work, phone numbers, emails, policies, etc., etc. And you are all welcome to try this later during our poster session. So now when you have all seen what we have done, you might also wonder how it works. So we will take a tour under the hood, and we have elected to call this the message lifecycle. And it starts with a doctor having a question. For example, which symptoms did my patient show? Yes, and then this is then fed into a so-called prompt. The prompt has 3 components. The first component is a system message, which you can think of as a set of instructions you want the model to follow. So, for example, you're a helpful medical assistant that, etc., etc. We then have a question or a query we want the model to answer. But right now, one thing is missing, and that is some background the model wants to be able to use to answer the question. And for this, we use a vector database. The Zenseact group already mentioned what it is. And it has this special feature called similarity search, where you can find semantics of 2 different text chunks and see how similar they are. So a query or a question that contains a patient ID 112233 is probably semantically similar to the text chunk with the same ID. So that is the text chunk that we want to use as a background. And we therefore put it into our prompt. And we now have a complete prompt with a system message, a query, and a background. This prompt is then fed into our GPT model. In the beginning, it was 3.5. In later stages, it was GPT-4, where the model then processes the prompt and generates an answer, which could be that the patient had some headaches. And this is finally then displayed in our chat interface.
Thank you, Oscar. Can you hear? Does it work? Yes. Good. So now that we know how it works, it might be good to reiterate some of the points as to why we actually might want to implement such a system. Last year or this year, ChatGPT got released. So from now on, the technology is available. It's out there. So both patients and doctors alike might use it very well. So to actually ensure that we can keep the data secure, sensitive information, records, medical records, we might actually want to implement a system so that we ourselves can actually ensure that it's handled properly. Additionally, we can also implement safeguards to actually make sure that the responses we get are proper and do not incite any harm. And the last, maybe most important point about freeing up time. By creating these systems, we can actually improve free up time from doctors, so they can actually spend more time doing more important things than looking for documents or finding information. So during the project, we also created a set of guidelines, and I will quickly go through them here. But if you want to read them, we have them available, and we can give you the link or give you the document straight away. So the first 2 are correctness and testing. And correctness relates to how we actually can encourage the model to give correct information. So as we presented before, we actually give the information to the model, and by giving the information we want it to use, we can ensure that the information that it does give out is more correct. But of course, it can still find information on its own from its training. So for that, we need to test it continuously to ensure that we actually get responses that are correct, even though we give it the information. The second 2 are tone and language, as well as user experience, and these are user-facing aspects. And these are about just adapting the system to the planned user. So for patients, for example, we might need to actually adapt the responses that we get from the model so that they give more clear and less technical responses so they can understand as well. As for user experience, it's more about customizability. And for example, a doctor might want to be able to change more about how the responses look or the language in them so they can actually get what is optimal for them. Then data and scope. Data, as we have mentioned already, is a problem in healthcare. You can't just send your medical records or information anywhere.
So by actually treating it and handling it in a proper way, we can actually ensure that it works and that we actually can do it. And one way to do it is to run models locally. Like we mentioned before, Llama 2 is a model that could be run locally. And by doing that, we could actually, avoid the laws around sending data away from the hospitals. Scope is about large language models. They are large, and as such, they can do a lot of different stuff. But by limiting the scope, by limiting what they can do, we can actually nail them in a bit better so they actually perform better as well. So we get less unplanned behavior from the models. So the next steps, we have developed a system that works, and it's really nothing more than a proof of concept. Of course, we cannot access any actual records or data. And as such, our project is not really applicable in itself, in the code itself, but it can, of course, be reused in parts. So VGR is planning a project, at least one, I know, about actually implementing a similar system to ours for, I believe, the intranet of their hospitals. Additionally, another interesting thing to look at in the future is the possibility of actually connecting a GPT system like ours to other AI models. So, for example, you can have like screening, cancer screening for skin marks model, and then you can actually connect them to each other, so you can get a proper text response that gives a clear view over what is actually presented from the other model. So before we wrap up our part of the presentation, I want to just give a quick summary of what we have done. We created 2 main assistants, one for doctors and one for patients, and they fulfill 4 different use cases: the patient, the doctor assistants, as well as the internet and the internet assistants. And then additionally, we have also created a set of guidelines that, as I said, you can get to read after if you want. With that, we want to thank Isak for guiding us, as well as everyone here at AI Sweden and at AI Competence Center at Sahlgrenska and VGR. And with that, thanks. We can welcome the next group.
Great, thanks for that amazing presentation. So, hello everyone. We're going to talk about how we can harness the power of generative AI for use by both students and teachers in learning. We have been working over the summer in collaboration with Chalmers and MIT, and we've produced some guidelines and we investigated the capabilities of these new large language models. But first, a short introduction of who we are. My name is Johan. I'm a civil engineer student studying engineering physics over at Chalmers.
I'm David. I'm a computer science master student at Chalmers. And as you all know, ChatGPT was popularized in late 2022. And unfortunately, after it began to be used by students all across the world, it led to bans by teaching institutions and even entire countries in some cases for education. But we don't like that perspective. We don't think that banning is the way forward. And we'd like to give you some perspective. So in 1970, the calculator was introduced, and this completely changed the way we do math. Math on paper is no longer as important, and unfortunately, this was banned though, and because it was seen as cheating in school. And in 1990, the internet and the computer completely changed the way information is retrieved. And nowadays, pretty much every intellectual job requires computer skills. And it took schools about 20 years to implement these kinds, the internet and the computer. And now, in 2023, we have artificial intelligence, which we like to think about as the next step that will transform education. And as we said, there's no use in banning these tools. We should adapt instead.
Right. So how does AI revolutionize education? Well, research has found that a private tutor can transform an average student into an exceptional one. And a UK-based study has found that an impressive 84% of students with access to a private tutor can improve their grade by at least 1 step. Now, consider a world where each and every student has access to their own private and personalized tutor. This could lead to a remarkable increase in unlocking student potential. And we believe that through AI, this world could be a reality. What's more, through AI, education is democratized. It enables students to access resources they otherwise couldn't. Previously, these valuable resources were often confined behind paywalls or within university gates, but in today's age, tools like ChatGPT can place these resources at your very fingertips. But what are some more specific things that the AI can do for both teachers and students? Well, with AI, teachers can create cutting-edge learning materials that captivate and engage students. And AI can act as an invaluable assistant for teachers, helping planning anything from individual lessons or lectures to entire courses. This in turn, of course, reduces the workload for the teachers. And for students, an AI can help facilitate what we call Socratic dialogue. It can offer a platform where students can freely engage in discussions without the fear of making any mistakes. And this helps develop critical thinking skills and make them understand things a lot deeper without the fear of any judgment. So I'd say AI isn't just changing the way we learn, it's changing the very nature of education itself.
And I'd like to show an example of just how easy this is to use. So here I ask ChatGPT to plan a lesson for young students learning multiplication. I also ask it to make a game in Python to aid them in their learning and have it as a part of a schedule. I also ask it to humor things like write the code, make a graphical interface, and make the window a bit larger. So we actually get a game and a schedule with the game so that these young students can learn multiplication, and the game is incorporated in this schedule. But let's be honest, this is not a multiplication magic adventure, really. And these aren't the kinds of things we've been working on. As Johan mentioned, we collaborated with Chalmers this summer, and we investigated the capabilities of these large language models, how you can use them in education, what they're good at, what they're bad at, limitations, etc. And we produced a report containing guidelines on how teachers and students should approach these things. And we also developed 2 proof of concept applications we would like to show to you. The first one, we call it EduChat, the AI textbook assistant. The idea behind this is that large language models aren't specialized on courses or textbooks, but we really like this idea. And we think that all textbooks and all courses in the future would really benefit from having their own assistant. But that's not really available right now, but we tried.
Right, so yeah, you talked a bit about the idea behind, but you can also take this a bit for further development. But keep in mind that this is just a proof of concept application, but there are many different ways you could take this in terms of further development. But I'll talk a bit more about that after this upcoming demonstration video. So it's very easy to use. You just upload your PDF of your favorite textbook that you want to study. And you can use this slider here to select how many pages you want to fetch. This will increase response accuracy, but also slightly increase response time. And you can ask it any general questions about the PDF. For example, here I asked it, can you tell me what the textbook is about? And it will give you a short but informational answer as per your request. You can even give it some more specific questions, like how and where does a textbook discuss or define a certain topic? And it will look through the text and answer per your request and tell you exactly how and where. Now, this is supposed to be tied to an education setting, so you can ask it to recommend you any exercises from the book that on a topic that you want to study. And here it will give us 4 different exercises directly from the book, nicely formatted. And since it's also supposed to maybe act like a tutor of sorts, you can ask it to explain to you how one would go about solving one of these. And it will break it down nicely and easy for you and anyone to understand. Now, one thing I want to mention here is that the behavior of this model is highly customizable. One might want a tutor to not give the student the answer outright, as it does here. So maybe it could guide the student in the right direction, making themselves come up with the answer instead. And like I said before, there are many different directions you could take this. One could, for example, implement this with a complete learning platform where you can track students' growth and teachers can see where they're struggling and where they need help. And then the AI itself could even generate assignments or quizzes depending on the student's level. And now off to the second application.
Yeah, so for the second application, we wanted to investigate how far we could take automatic correction of student code. And we wanted to see if we could reduce the workloads on teachers and teachers' assistants. So this thing we call code corrector, corrects code, provides feedback on what's good and bad. It actually dynamically with Python, it runs code as well currently, so you can check if it passes tests. And this can be further developed, and and the idea can be expanded on. But how it looks right now is you tell the program what the assignment is about, and you give it a few tests to run, so you can see if the student code actually gets the correct output with the specified input. And you can upload as many student code files as you like. So you could upload hundreds, 200s if you have large courses, for example. And then it runs the code and it prints these feedback. Here we see a student who wrote code that passed. It gives some examples on what's good and what's bad. It goes into specifics on what type of improvements the students can do. And over here, we have another example of a failed code. It says that the student code crashed and it prints an error. And here it's actually, this code is actually created by GPT 3.5 itself. So the assignment was a little bit tricky. So it actually failed. But what's interesting is that it says here, it explains to itself why the code failed. So it knows somehow. But these aren't the only things. There's actually large corporations working on implementations. Yeah.
So one key point that we want to emphasize is that the things we're talking about isn't some distant future. They're happening right now. So I've gathered 4 examples here of how generative AI is implemented in education today. The first one is called OpenUni or KTH GPT. It's a transcription-based tool that creates notes of recorded lectures, and then users can interact with those notes and get assistance with any related assignments or questions. Second one is Khan Academy. You've probably all heard about it. They have a tool called Khanmigo, and it's their AI-powered guide, and it acts as both a tutor for learners and an assistant for teachers. The third one is Quizlet. They have a tool called QChat, and it offers personalized learning study paths. And it can gauge a student's level and then offer appropriately difficult study material for them to learn more. The last one here is Otter.ai for education, and it's another transcription-based tool, and it's a tool can make notes of any virtual or in-person classes or meetings. So in summary, these are just 4 concrete examples of how AI is making an impact on education today. Like I said, it's not about some distant dream. It's about the tools that are already available and shaping the way we learn and teach now. So beginning to wrap up here, I have a few takeaways to mention. One thing we came to realize that there really isn't endless possibilities for both students and teachers when it comes to how generative AI can be implemented. This, of course, means that adaptation is crucial for staying competitive and ahead. And this also rings true for universities. They want to uphold a strong reputation for employability. They need to teach their students on how to use these new tools. They also have to adapt. So in conclusion, I would say that AI is really making an impact and we gotta adapt.
Yeah. Students need to know how to use these tools when entering the workforce because these tools are key to improving productivity and work output. We should absolutely not ban these tools. In this day and age where information is so widely available through the internet and these large language models, teachers are no longer gatekeepers of information, but rather facilitators. We must adapt and embrace rather than ban and shy away.
So thank you all for listening. But before I hand off to Sophia, I want to say a few words about AI Sweden and the program. So I speak for all members of every group part of the summer project when I say this has been really fun. From learning about LLMs to getting our first response and building web applications and interfaces, it's really all taught us a lot. But one thing that we were surprised about, though, is how much easier it was than we thought. And really hope that you all take that with you as well. And the most important thing is just to start. With that said, thank you to AI Sweden and all the partners involved in making this possible. And a special thanks to Mats and Sofia for getting us up to speed and feeling us welcome at the office. We'll soon leave for the post session, but first, Sofia will say a few words. But thank you all again.
Thank you very much for all these wonderful presentations. We will soon say goodbye to those of you who are online and move on to the next room for a poster session where you will be able to ask questions to all students. I think that we have seen some great examples here today on what can be done with boldness, speed, and collaboration, which I talked about in the beginning. With little means, we can get big results. We just have to start. We just have to do it, as Johan just mentioned. And we look forward to keep developing on this initiative. And there are a few different ways that you all can get involved. On My AI, you can read about all 3 projects and follow the progress week by week. In a short while, we will set up a sandbox together with some partners, which will become an environment for all partners to explore and experiment with the GPT. And a sandbox is something which allows for testing, in this case, testing generative AI in a controlled and safe environment. We are planning a master thesis program with a special focus on generative AI, and we welcome master thesis proposals from partners already now. And of course, we would also like to arrange this summer program next year together with some of our partners. On AI Sweden Open House Day, Generative AI, there will be further elaborations on generative AI, demos of GPT applications, and presentations of business cases. So you can register in Stockholm or join online on September 19th. So please go ahead and register on ai.se by following this QR code. And I will also send out the link to everyone who registered for today. And if you register, you will get information about all options on how to get involved, links to My AI, the sandbox, master thesis proposals, and registrations to the open house day on generative AI. So thank you very much for joining us here today, and let's move next doors for poster sessions and coffee and cinnamon buns. Thank you.